resistance boxes and determining the resistance from our multimeter. What's really going on here, though, is built within the box are various small resistors that as you turn the dials, you're having them connect up in various ways in series and parallel. What I want to show you now is that we can also examine individual resistors. So what I have in front of us here are packets of resistors labeled, as you see, 22 ohms, 10 ohms, 3300 ohms, and we do have ranges that go much higher than this. If you take a real careful look, though, you'll notice that each one of these are color-coded. There are 4 rings of color that are associated with each one, and this is one aspect you're going to learn in the Ohm's Law lab, is those, if you're skilled in reading those, you can, without even knowing these numbers, to a certain accuracy, know what the value of these resistors are. So you'll see that. But let's go ahead and take a quick measurement of one of them. I pulled one out of the 22 ohm bag. And let's connect him up to our meter and see what kind of reading we get. So we need our gator clips in order to do that. So we attach to each side, and I've already dialed the meter to the 200 ohm setting since the bag told us it was less than 200. So to get us our greatest precision, we see that we have 21.9 for our reading, which is certainly within acceptable tolerance, where these resistors are designed to be either 5 or 10% usually acceptable. Okay, so now that you've seen that, we'll be using individual resistors as well as resistance boxes, depending upon the situation, to introduce resistance into our circuit. So let's move that aside, and I want to show you that resistance can also come in the form of wiring itself. Any wires themselves, depending upon what material, usually copper, conducts the electricity, offer resistance. And so that, to convince you of that, we have a series of resistance coils which are mounted onto here. There's a total of 5. And these are the ports that we can access, plug into that is, that can tell us what is the resistance of each of these. And so the ports that I'm pointing at now, I just flip it over. You can see that these are the contact points that are on the back side. And so a quick word about the coils themselves. This first one here, you can get an idea of what's happening if you read on the very bottom. This is 10 meters worth, believe it or not, of wrapped copper coil. And it says number 22. And what that refers to is the gauge, or the thickness. So to get a feel for that, if I point to the next one over, this one is also 10 meters of copper, but it's rated at number 28. And so you can see that this is a much thinner wire, must be, if they're both 10 meters. So the larger the number must refer to the thinner the wire, or change in gauge. And there are conversions that you'll be given to tell you exactly what kind of diameter wire we're talking about, in which case you can compute the cross-sectional area of them. And that'll be useful to tie in with knowing the resistance of the wires based upon their materials. So all 4 of these are copper, and this 5th one over here is different. It's nickel, silver, it's a certain alloy. And so let's say we just want to check the first one. Alright, so we can do that with our meter real quickly here. We can plug into these first 2, and what that'll do is that'll give us a reading for the amount of resistance present in the 10 meters of this gauge copper. And you can see it's pretty low, 0.6 and 0.6 ohms. Well, while that may not make the huge difference here in lab, sensitive enough labs where you're doing work, it might. And so if we just move over to the next one, which, remember, that's the thinner copper, we see that we have a different resistance that's being offered, 2.2, which is a larger resistance. So there must have been some difference between these two. They're both the same length, so that's not the factor. They're both the same material, but they're different gauges. And so if this is correct, what it's telling us is that the thinner the wire, the greater the resistance. So we'll be examining that and see how that works out mathematically. So we can check all of these. We can even check them all at once if you really wanted to. We could do that. And that way we can get the resistance of all these at once, since now we're measuring it in series. And so even if you put all of them together, you're still looking at less than 20 ohms of total resistance, or 17.5. So this is another aspect of our Ohm's law lab.